Okay, and now we're going to continue our discussion about IP networking and talk about designing IPv4 networks. Now, I'm going to go a little bit against the grain of what you may have been taught, including from me, and not describe the way that the book or Cisco may want you to design the network, but the way you would actually do it in real life. So for instance, if we look at this first network, and if you've seen my video about VLSM, you may look at this and you may immediately start recognizing sales is the largest network, then marketing, then admin, and therefore I need to start sizing them out this way. See sales with 185 hosts, that's going to need a /24. Marketing with 50 hosts, that's going to be a /26. Admin with 30 hosts is going to be a /27. And then right here in between for my WAN connection, that's going to be a /30. Let me check my notes, make sure that those are all correct. Yes, those are all correct. And this would be the way that Cisco would want you to do it on an exam, or that I may want you to do it on a test. However, the way you would do this in real life is completely different than this. In fact, there's probably two different ways you would do it. The first one I would call a Class C. Now, if you know what a Class C network is, hopefully at this point, you know that has a subnet mask of 255.255.255.0, which means that this last octet right here has to do with host IPs, whereas everything before that has to do with network IPs. So a Class C, because the break is right there at the dot, right at the final octet, makes it a very easy way for me to be able to manage the networks. Additionally, it allows for up to 254 usable IPs. And when I look through the environment here on my diagram, no one environment is even close to 254 IPs. Possibly sales when I start accounting in for growth. But so I could easily do a Class C network here. And basically what I do is I would just start off by numbering these networks. Now computers, they all start with zeros. So I'll start just my admin environment, I'll call area number 0. Marketing, I'll call area number 1. And then sales, area number 2. What I would then do is I would simply add or use those numbers for my IP addresses, specifically this third octet right here. So my administrative area would be 172.16.00/24. My marketing 172.16.10/24, and then lastly sales 172.16.20/24. The only place where I would actually start using VLSM is this right here in the WAN environment, because there's only 2 IPs and I know there's only ever going to be 2 IPs. In that case, I probably would go extremely far out into the realm of saying this is going to be 172.254.0/30 or something along those lines. So then I have essentially, well, here's my first network, second and third. They're all Class Cs. They're easy for me to manage and administer. I don't have to worry about funky routing tables or firewall rules. I simply allow one network or another. The only place where I have to worry about weird masks is right here in the WAN. And 99% of the work I'm doing is not going to be administering the WAN, so it's not that big of a deal. So it saves me a whole lot of time and space. If another network comes along, well, I simply just add in 172.16.3.0/30. 24. Well, great. That makes my life a whole lot simpler. Now I can simply just organize everything according to one network gets one Class C network. Maybe one office, or like in a classroom environment, one classroom gets a Class C. One group of offices gets a Class C. All of the HR people get a Class C. All of the executives get a Class C. And they all pull from those different Class Cs as is appropriate for their environment. So Class C is probably the easiest way to be able to separate these out. Now the second alternative is going to be supernetting. So it's still going to be using Class Cs, but it's going to be using a process called supernetting. We've already talked about subnetting. We're talking about taking a large network and making it smaller when we subnet. We're making a sub portion, a subnet. Here with supernetting, what we're going to do is we're going to take a lot of those subnets and group them together. Now, I'm going to be drawing it on here because of this WAN link right here. This WAN link suggests these might be two different buildings. This might be building A, and this might be building B. They may be in different cities, they may be in different countries, and therefore I may want to simplify my routing between them. So what I may want to do is I may want to split half of my network on one side and half on the other, or maybe a quarter from one side to the other. So I'm going to do it by quarters. So it's going to be a /27. No, excuse me. That's a. So this right here currently is a /16. 16. So what I'm going to do is I'm going to put a /18 on this half of the 18. Excuse me, on this half of the network, and a /18 on that half of the network. Okay, so let's go ahead and let's start with that on the left-hand side. So again, this is going to be 0. This is going to be 1. So for the first part, it's going to be really, really simple. 172.16.0.0/24 and 172.16.1.0/24. Exactly the same way as we did with the Class Cs. And that's for building A. So that's a /18, which means the first 16,000 addresses in this 172.16 range is going to be going to building A. So this is ultimately going to be 172.16.0.0 through 172.16.127.255. Anything in that range, anything that starts with from a 0 through a 127 goes to building A. Well, I then do the same thing on the other side. No, not 127, excuse me. 63. I forgot I broke it into 4 chunks, not 2. So then building B is going to continue on where that left off, 172.16.64 0 through 172.16.127.255. So then anything with a 64 through 127 then goes to building B. Well, again, start off with 0. Now math starts coming in a little bit. 64 plus 0 equals 64. So this is going to be 172.16.64.0/24. Now the cool thing is if I start adding more and more networks on either one of these routers, I can make it so that everything from 0 through 63 is in building A. And my routing table can be really easy of saying everything from 0 to 63 is in building A. Everything from 64 through 127 is in building B, and I can even have a couple more buildings here and continue to make sense out of it. Lastly is the WAN link. Again, just like I showed before, I would probably choose one of the later networks. So 172.16.254.0/30. Can't read that red on red very well, but that's a /30 in order to assign the IP addresses to my routers. So two different ways. You can either use a class C where just everybody gets a class C except for the WAN link, or you can try to plan ahead and say, I think I'm going to start adding in more networks in building A and possibly more networks in building B. So I'm going to supernet them and then have the individual routers separate out from that point. So let's try another example. Here we have, well, let's see, we've got 3 buildings. So Dallas, Washington, and New York. And then 2 WAN links. So again, basically starting off with a class C. This one gets a little bit more hairy here. Dallas, I'd start with 0. Washington, D.C., start with 1. And then New York, ooh, that's more than one class C network can handle. So that would be 2 and 3. So starting off with 135, 126. 00/24. And I'm just starting from the left because I'm starting from the left. Washington, D.C. would then be 135.126.1.0/24. And then New York would have 2 networks assigned to it. 135.126 2.0/24 and 135.126.3.0/24. Now, could the routing to New York be optimized? Absolutely. I could use the /23 instead. I could even use the /22 instead, or some other smaller, larger network or smaller CIDR number. However, from an administrative point of view, this is probably the most optimal or most clear method of simply describing these 4 locations and the networks associated with them. The WAN links, well, again, start up with a higher number, so 135.126 254.0/30, and then 135.126 254.4/30. 30 takes 4 IP addresses, so I start off with 0 here and then go to 4. My next WAN link would be 8, 12, and so on. And then lastly, well, here we have 4 different classrooms. And again, if you're taking this on a test, specifically a Cisco exam, it's going to care how many hosts you have and expect you to make the smallest possible network. For us, that's not that big of a concern. I'm going to assume routers are connecting all of these together. So 0, 1, 2, and 3, and then 210.15.10.0/24, starting it at 10 because it already has a 10, and then 210.15.11.0, 210.15.12.0, and 210.15.13.0/24. I was a little taken back by this diagram because this is the way I would do it if everything was routed. However, I'm seeing right now there is only the one router, so ultimately I would have one class C that way and one class C that way, and then the 2 rooms are switched together. So there you go. That's basically how I would do it if this was a production environment and not a classroom / testing environment where you're given instructions to make it as small as possible. Basically, make everything use a Class C as much as possible. You can use the supernetting in order to separate, say, different buildings or separate regional locations. That does require a little bit more forethought and planning to make sure that those super regions have a large enough number of subnets for today as well as for growth. However, easier, especially if the environment starts to get pretty complicated. Otherwise, the Class C networks, again, is just kind of rule of thumb. If you're going anywhere in production, use a Class C. It's easy for even the most inexperienced engineers to understand, and makes firewalling rules easier for everybody that might be included.